Okay, welcome back, everybody. Here we are with application tuning for CA Datacom environments Part 3. We ran out of time on Part 2, so we added a Part 3 at the last minute. Hope you guys will enjoy it. Special thanks to Owen Williams for staying so late to go ahead and do this additional presentation. I have tried to mute everybody from my end, so if you need to ask Owen a question, please do #6 on your own phone so that you can unmute yourself. So go ahead, Owen, and get started.
Okay, thanks, Nancy, and thanks to all for joining, and to CA for arranging this Part 3. I obviously had too much information in these sessions, so very grateful that I'm not having to rush it, and I can give you the extra detail on these last slides. So let's get going. Yeah, good. So this is actually a 3-part session now. There we go, for the application developers. So the remaining topics we've got are some ideal programming recommendations specific to tuning ideal applications, looking at the tuning tools that we have available, the other resources that we have available for getting answers to questions, and a brief summary of what we've covered. Okay, so ideal programming recommendations. Now, ideal is a very powerful language. It's very simple and quick to develop applications in ideal. That's why it was invented. But there are some things that we can do to improve the performance, particularly the CPU performance of ideal applications, particularly around some of the built-in functions that people tend to use. So the first one of these we're going to talk about is substring. It's a very CPU-intensive function within ideal. So the golden rule with this is never code a substring where you know both the start and length, where the start and length are fixed numbers as opposed to variables that might change during the runtime of the program. We really don't want to be having fixed values in there because it's a waste of processing. Instead, you should break that field into a group field and reference the data directly with it as a simple field. And also, don't repeatedly use that same substring function unnecessarily. Otherwise, it's going to recalculate that substring each time you execute it. Unlike things like COBOL with the optimizer, where it will optimize the code to a certain extent and eliminate that duplicate processing, it won't in ideal. So it's up to you to do that in your programs. So let's look at an example of one of these. So here we have an input record that's coming in as 80 bytes, just 80 bytes. And we've got a select statement here where we're calculating the substring starting at 70 for a length of 3. Is it equal to ELM or DVW or PGM? Now you can see I've got fixed values here. Yeah, so it's going to recalculate this every time I execute it, and it's going to recalculate it essentially 3 times every time I execute the select statement. Yeah. Instead, if we break the group field, the FRA data, into its constituent components, so we're not interested in the first 2 bits, so we'll call them filler. This is the one we're interested in. We get rid of the substring altogether, yeah, and now we're referencing the field as a direct field. It's much more efficient. So that was substring. String is also a CPU-intensive function in ideal. What actually happens under the covers is the data is copied to a temporary work area. The extra columns are appended, and then it's copied back into the target area. Yeah. Now, a major new feature and major new enhancements in ideal release 15 is the document feature. If you're doing a lot of things with string, particularly if you're doing it to build up XML documents or HTML pages or other large strings like that, much more efficient to use the new ideal document feature in release 15. So do have a look at that. But if you are doing $string, then again, don't repeat the same function unnecessarily. So set the result into a simple field and then reference that instead. So let's look at another example. These are all real-world examples of code that I've found in people's programs that we've fixed or enhanced to improve the performance. So here we have a loop. It's going up through an array, but it's comparing an item in that array to this string of these three columns strung together. Now notice that these 3 columns in themselves don't have a subscript. They don't depend on this subscript. So the value of report program status and data view, yeah, is the same on every iteration of the loop. So the string can quite happily move outside the loop without impacting the results of this loop. Okay, Now, while we're here looking at this particular piece of code, what else can we improve in this loop? Try to avoid looping through the whole array. In this case, all 640 entries are searched if the incoming item is not a duplicate. Let's come back and show you that thing here. So because he's going through, that's a fixed value here. Yeah? If it's a duplicate, he's jumping out on the until duplicate clause. If this item is not a duplicate, it's going to go through all 640 times. That's not very efficient. Okay. Instead, when you're loading up the array, store the maximum number that you've loaded into the array as a value and use that to terminate the loop. Also, avoid retesting the same terminator on each iteration of the loop. I'll show you the resulting code, and that will explain what we've got here. So here's our original code, yeah, with the string inside here and looping 640 times. What I've done here, I've moved the string into a new program data view field. It's only being done once. I've added a label here for the loop. We'll see why we do that in a moment. And now I'm looping through the array, not up to 640, but up to a data view max. The data view max I've set in the initialization when I loaded up this array in the first place, so it's not 640, it might only be 250 entries. So the maximum we're going to go through is 250 if there's no duplicate here. If it finds a duplicate, just do a normal comparison here, not against the string, because that's already been set up here, then set the duplicate, and we quit this label, okay, quit this label. Now, I know some of you will raise your eyebrows at this, because at some sites, quit has been banned as a bad thing to use in programming standards. Personally, I don't see any problem with it. It's a perfectly valid statement, and there are good reasons to do it. This is a perfectly reasonable one, I think, here. But if it is banned at your site and you really hate quit, then the alternative is to do it this way. Again, as we move the string outside, I just loop up through the array and just looking for the match that's in here. Notice that I'm not doing any processing of what to do. There's no if statement inside here. Okay. What happens if there is a loop? If there is a match, then the value of sub2 will be the item in the array that matches that value. Yeah. If there isn't a match, then the value of sub2 will be 1 greater than that maximum value. Yeah. So here I've got no quit. I'm just looping through, looking for the duplicate, and then after the loop, I can then test whether a loop was found. So if sub2 is greater than DVW max, then we haven't got a duplicate. If not, if it's less, then we did find a duplicate. So here's the same piece of code. Either of those two solutions will work equally as well. One uses quit, the other one doesn't. Okay. The next thing is to avoid unnecessary internal sorts. Again, I keep banging on about this, but it's true. With portfolio simplification, you've all got access to SQL now, part of the base products. So you should really use SQL to join and aggregate and sort the data into the required sequence, because there it's moving the work into the MUF, where it can be using a zip CPU. If you can't do it, if for some reason you can't do it via SQL and moving on to the MUF, then use the sorted report facility of IDEAL instead, if it's appropriate, rather than sorting it internally in your program. If you have a really complicated situation in your programming that really is no other option but to do an internal sort, then avoid repeatedly calculating the index subscript within your sort. So calculate the subscript -1 once and use that in all subsequent statements. And also, instead of moving each individual element of the array, have a group field which covers the whole array element, the whole row of the array effectively, and move that at once. Let's see an example of that. This is again a genuine piece of code. This was actually causing an AICA, a bend in Kix, because it was consuming too much CPU. Kix thought it was a runaway task. So they're looping through the array, and here they're moving each of the individual elements of the array. They're swapping them out using this sort of double sort method we've got here. Okay, but here they're recalculating that sub -1 8 times, 4 times here and 4 times there. Okay, what we've done here, again, we've consolidated the array, these 4 elements into a single array row, which I've defined in working storage. Yeah, I calculate the sub -1 once, and I refer to that sub -1 value, which is now in sub2, in the 2 items here. So I'm only calculating it once per iteration of the array, and I'm moving the whole array as a group. You know, much more efficient. It's actually simpler. It's easier to read and understand what it's doing. So it's better code, and it's much more efficient, and it stopped the AICA band. $trim, also a CPU-intensive function. When building your output text strings, avoid repeatedly trimming the trailing blanks or whatever from the same input strings. I've seen cases where people are repeatedly doing the same trim. Typically, when you're reading Datacom data, very few people use variable length fields within Datacom. Or there are cases when you should look at actually defining those now. But most of your data you'll find is in fixed length columns. So if you're building lots of variable length data, particularly if you're building XML documents or HTML documents, convert it to variable length in the working data once with the trim, and then reference that variable length field instead of repeatedly trimming the column. If you're appending to an output message string, something like an XML document or etc., then define the output message string as a variable length working data field. So then you don't need to keep trimming it each time you go through. And again, I'll advertise the Ideal 15.0 document feature as a really great enhancement for when you're generating those XML pages, etc. So it's particularly relevant when you're building messages for IBM MQ series, web interface, output documents, HTML documents, XML, all of that. Right, let's come on to reinitializing arrays. Again, the change in the mainframe environment where we have much more storage available to us now, certainly in batch, storage is cheap, whereas CPU is expensive. Because remember, CPU in your application is running on the general processor, not on the zip. So if you have to clear an array as part of your processing, you process a batch of rows, and then you need to clear down the array, and you process the next batch of rows. I've seen people looping through, initializing the individual elements to spaces and zeros, all that kind of thing. Don't do that. At the start of the program, or in fact, just in working storage with values, value statements, either in Ideal or COBOL, this is both perfectly possible in both of them, keep an empty copy of the array in working data, which you never touch. And then when you need to clear it down, you just set the real array to the empty array by position. Very efficient. Single statement to do it in Ideal, very easy to read, very easy to maintain, much, much more efficient. The same applies in COBOL as well. You do exactly the same function. It's just a move instead of a set by position. In Kix, where storage is not quite so cheap, so that method may not be appropriate if you've got really big arrays, to have a second copy of a really big array in storage. But again, even in a Kix environment, a lot of the time, there's more storage available than there used to be 10, 20 years ago. So consider, take it on a case-by-case basis in Kix, but certainly in batch. You should definitely eliminate reinitializing arrays manually within your application code. If you're calling non-ideal subprograms, make sure you have linked the subprograms with the CE UOPT RTE reuse equals on option. That's the runtime environment reuse. Yeah? This ensures that the LE runtime environment is only established once. You may be calling this COBOL subprogram 1,000 times in your execution, but it only establishes the LE environment once in this case. Otherwise, it throws it away and reestablishes it all on each call. Two advantages to having this. It means the working data is preserved between calls. You don't have to keep reinitializing all your working data from the parameter section on each call because it's preserved for you. And it makes a big performance improvement if it's a heavily called subprogram. Coming on to inserting or updating an existing row. I've seen programmers that pick one style here and stick to it because that's their style. They prefer to read first, and if it fails, then they insert. Other programmers prefer to insert first, and if it fails, then they read and update. It's very important that you actually get to know your data. What is the most frequent thing that's going to happen in a real runtime environment? If the row is almost always going to be present, then it's much better to assume that and say, I'll read it and update the values, and I'll only do the insert if the read for update fails, and if it didn't find a row. Yeah? Whereas if the row is usually not present, you should do the insert first. Try the insert on the rare occasions when you hit a duplicate, then you do the read and update. Yeah? So get to know your data and code the full constructs appropriately. Equally, this would apply to COBOL as well if you were doing it. The same principle applies there. Okay, a quick note on Dataviews and elements, particularly for anyone who's not really familiar with Datacom. Elements are unique to Datacom. It's a Datacom-only concept. It's a collection. Dataviews are a collection of elements, and the elements are actually the things. This the element of transfer. When Datacom is populating the work area to send the data back to you in your request, then it's the element that gets moved, not the individual fields. Or you know, not as a whole by default. So again, I've seen sites that have standards in there that say, oh, we use single field elements, and that there's perfectly valid reasons for doing that. If you have single field elements and you've got a row with 200 columns in it and you're returning them back to the application, Datacom has to move each one of those 200 columns before it can send the data row back to you. Yeah, which does have some cost. But of course that cost is on the zip, because that's on NUF, so it's less of an issue these days. The benefit of single field elements is that it provides isolation from other table changes. If someone adds an extra column to the row or changes a column that you're not interested in your program, then you don't have to touch your program. So there are really good benefits to this, particularly if you're agile and DevOps, and effectively SQL does this, because SQL, the column is the unit of transfer when it's returning the row. An alternative is that you have one defined as the whole row, and you use that. You definitely want to use that where you always want to reference the whole row. So cases where you're inserting rows, of course you want to have the whole row. You know, if someone adds an extra column, you need to know about it, and you need to have that in your program. So it's going to cause an update to your program anyway. So it's certainly worth having a whole row element for that, and data view for that. Also, if you have data views that only have elements that contain key columns that are part of a key, then Datacom does index-only processing. It doesn't go to the data area at all. It just, because it knows it can get all the data to satisfy your request and send it back just from reading the index. So my recommendation at sites is that you have a mixture of data views. You don't stick to one standard, yeah? That you have single field elements for the cases where you only want a small subset of the row to be returned, and you use data views that are appropriate for that. Because again, particularly when you're using sequential read ahead or other things like that, Datacom can return more rows in that block if you're just returning the columns that you're interested in. You should also have a data view that is defined as a whole row, related to a whole row element, for use in insert programs or any other program where you know you will always want the whole row, because it's more efficient for Datacom to do that move as a one-block move, or particularly if you've got a very long table in terms of number of columns, then you return it from that. So have that available to you as well in your toolbox. Also define a data view that has the primary key or any other keys, secondary keys that you have, so that you can take advantage of index-only processing. It will greatly improve the performance. So only having to do one index buffer reference instead of index buffer reference and a data read, particularly if you don't need any of those columns that are in the data row that aren't part of the key. So do have those available to you as a selection in there. Okay, so that was some ideal programming tips. Now I'm just going to move on to some of the available tuning tools that we have available to us. The PXX has always been there. We have job statistics that are created. Now, a lot of sites, they've turned these off, and it's valid to do that because it saves the resource of writing statistics that no one reads. But it is available to you to switch that on, either at URT level or generally at NUF level, so that you can get those statistics about the table reads and updates and all of that. And that can be a very useful tool without having to define accounting tables or anything else, just to give you an idea of where the majority of your processing is within a particular program. You might have a big ideal program that accesses 50 different tables, and this will give you an idea of where it's spending most of its time just based on the number of requests that are issued. Similarly, if you're trying to tune a program that's doing a lot of updating, then just looking at the RxX reports, either through read RxX or through the report area equals RxX function that's now available in DButility to be able to track those maintenance activities and the times. That can be a useful tool after the event to find out what happened to a job, why it ran particularly a long time. We had a case recently where a program, we had a complaint that a program had taken a lot longer than usual, and when we looked just at the RxX reports, we were able to go back to them straight away and say, well, yes, normally it only processes 1,000 rows. This time it processed over 1 million rows. So why was it processing so many extra rows this time? But that was the reason for it. Datacom accounting, it can be a very low overhead if you define it correctly. It can also be big overhead if you define it in great detail, but it can be very useful both in test environments and even in production environments to analyze the physical logical IOs, the CPU consumption, the huge number. It's a very, very complicated or very flexible environment to analyze your system, but it does require manually set up, typically by the DBA, to provide that information. Okay, the dynamic system tables can give you a lot of information. Again, if you're in a standalone test environment, you're able to have the exclusive use of your own test multi-user, and you're running the production suite or a copy of the production suite through it. Dynamic system tables will give you a very good information about the IOs and the table requests and all of that information that's in there, as well as being able to show you the MUF active tasks that are currently running, including for Ideal and Metacobol, the specific program version and statement number that's being executed. So if something's taking a long time, you can actually look at that user information block to find out exactly where it's spending all this time in the program. Auto info, auto status, auto collect. These are more DBA tools really, but again they can be used by development teams. If you have a standalone MUF for doing UAT testing, for example, then you can do that. You can use that to monitor the overall performance of the environment. So again, you can spot where there are contentions. Auto status can, it keeps historical information, so that you can see the reason a particular job was waiting, because it was on wait exclusive control for another job that hadn't released a row, and so follow it through there. So that can be very useful for that historical information. Whereas the dynamic system tables are always a snapshot of what's happening right now. Auto status, auto collect is historical information that typically you would keep for about 3 months worth of data we keep, so that we can find that information historically about applications. The multi-user shutdown EOJ sysprint provides a lot of statistical information about how the MUFs have been going on, so that can be useful again in UAT environments to see an overall picture of how the database operated with your test run, if you've been running a whole test suite. The CBS diagnostic trace, so I mentioned this earlier, the $$ in the first 3 characters of the UIB, or set run CBS trace on, provides very detailed information for Datacom database access tuning. And the SQL plan message options, if you turn MSG equals S for summary, that's usually all you need. Or you can, even if you don't want to, you don't have the opportunity to change the plan options, which, by the way, you can do even for a production runtime plan just using DDOL. You can go into the plan options and do it on the fly to update the message options. But if you don't have the ability to do that for some reason, then you can turn on SQL traces using DB utility. So without touching your plan, without touching the program, you can turn on the trace, let it run through, and just look at the trace output for that one run. And those message options, as I mentioned earlier, have improved greatly in terms of being more user-friendly and more English in terms of their explanations of what's been going on. Other tools that are built in with the product, the Kix debug facility. So if you've got online applications, DBUG, the debug facility, will allow you to step through, just as CEDF does for the Kix calls. Debug will let you trace the Datacom requests that go through. Ideal debug facility. A lot of Ideal programmers don't realize this is here. Instead of run program name, it's debug and then program name. And yes, you can run it in batch, so you can use the debug facility in batch. And you can even run it in runtime in only environments. So even though your source program might only be in the development environment, and you've used object transport, or you've converted to load modules and promoted up those load modules to your production environment, the debug facility all still works absolutely perfectly in a runtime environment, and it will still show you the working storage field names and all of that. The only thing it can't show is the procedure division itself, but it can show you the line numbers that you can then refer back to in your development environment to see how they tie up. Very, very powerful tool for debugging in IDEAL. The other thing, if you have Enterprise COBOL that comes free with it, is the IBM debug tool. It's pretty basic, but it can be very useful in debugging COBOL programs. It's an interactive debugger, so you can set it up for that. It does require some setup, but it is available because it's part of COBOL. Other application tuning tools that are available for use with Datacom, CA Intertest is much more functionally rich than the basic IBM debugging tool. One favorite thing that I use is the code counting feature to identify heavily used statements. So when I'm trying, I might have a huge COBOL program that I'm looking to tune, but if I do the code counting, it will tell me exactly which section of the code, it might be many, tens of thousands of lines long, this COBOL program, but it'll show me the 20 lines that the program spends most of its time in. So I know if I tune that little bit of code out of this huge program, I'm going to get the biggest bang for the buck by tuning how that bit of code works. So very, very powerful. Intertest is a huge tool. And you saw in earlier sessions today the new development environment for System Z. The Intertest is one of the things that's very much plugged into that in order to be able to debug your programs and step through them. Brilliant facility that Intertest has to be able to do that. CA SysView is a brilliant tool for analyzing the current activity of the program. We've actually extended SysView with our own line commands. It's very easy to add bits to SysView, so that if we have a looping application, I can drill down from the DT tasks display, the Datacom task display, and it will show me the actual request area in the application region and the work area in the application region. It's all very easy to do in SysView. So you can actually see as it's running through, your manager's on your shoulder saying, when's this job going to finish? And you can actually see the rows going through in your application region and say, oh, right, based on that, it's actually 20% through the way through, so I can now calculate when this job's going to finish. SysView is fantastic for that. We've had sessions on SysView before. It's basically, as far as Datacom's concerned, it's a snapshot of what's happening right now. For KICS, it does also have this KICS transaction log. So if someone phones you and says that a KICS transaction was running really slowly at 10 a.m., well, that's no good to you when they've just told you about it at 3 p.m. You can go back to the KICS transaction log and look at that execution of the KICS transaction. And if you set up the DCC TXPR, this is your KICS systems programmer should have done this, then it will show you for that transaction how many what tables it accessed and how many requests, inserts, deletes, reads, all of that in detail, so you can then tell again, the reason it was running much longer is because the user selected a product code that has 20,000 orders attached to it. So that's why it took long, because it was processing 20,000 orders. Very powerful and useful tool, the KICS transaction log in SysView. A relatively new tool, it's only been around for a couple of years now, is the CA Mainframe Application Tuner. For any of you who are familiar with other products, it's a sort of equivalent to Strobe, but cheaper and better. It's a major new tool for IDEAL and COBOL and other programming languages as well. Now, because it runs completely outside the application region, has virtually no overhead to the system at all. There's no recompiles required or special compile options or anything like that. And you can have it monitor the sort of from afar an application that's running, and effectively it will do things like that code counting I was talking about that Intertest does, and tell you the section of code that it's in. Very, very powerful thing on that. And we've had sessions on Mainframe Application Tuner before, but if you want another one, I'm sure that CA will organize one of those. Other resources that are available to you, I'm just going to do a shout out here for Cadre, the Cadre on the CA Communities site. This is the address of Datacom Cadre. We tend to get a lot of people joining who are DBAs and systems programmers, and that's great. We welcome all of those along. We don't have many people coming to Cadre who are developers, and we'd really like to encourage you as developers to sign up to Cadre on CA Communities. It's free. It's a bulletin board. It's a place to ask questions. There's lots of webcasts and other things that are available to you there. And there's no such thing as a stupid question. If you post something on there, there's a bunch of friendly people across the community who will quickly come back and answer your question. So please do ask your questions. Share your experiences with the developers across the globe. It's all very well asking CA things, but they know how the product is written and how it works and all that sort of thing. This is an opportunity for you to connect not only with the CA folks, because they're part of this community as well, but also with other developers across the globe. This is also where you can submit your ideas for products enhancements. And I mentioned in part one that we really do want to hear from you if you've got ideas that you would like to see, things that would make your job faster. Whether it's, for example, to be able to do a sort change on an ideal display index command so that you can quickly see, what were the last programs that were the most recently changed, or whether it's a piece of SQL syntax that you would like to see added to SQL. So please do submit your enhancement requests, to the CADRE bulletin board on communities. Also available to you is support.ca.com, CA support. You do need your site ID to be able to sign into this, so you need to prize that out of your DBA's hands to sign up to that, and you can ask questions from the CA support staff. They've decades of experience with these products, and they're always very helpful. They like questions that they can answer quickly, and they can close the case then. So please don't make use of this resource. It is available to all Datacom and Ideal users. Okay, so just to summarize what we've had in these 3 sessions that we've just had now. So what we were aiming to do, we're always being asked to do more with less. So we were asked to reduce the total cost of ownership of the mainframe while still maintaining or even improving the performance of the environment and the Datacom applications. So our results when applying this application tuning I've been going through here, we now have more Datacom tables than we ever had before. We have more rows in those tables than we ever had before. And we have more applications processing them than we ever had before. We now have faster response times across the board in batch, server, and kicks than ever before. And we have reduced the MSU cap on this CPU, on this mainframe, by 30%. So that's reduced the total cost of ownership of the mainframe. And as a result, the mainframe is no longer the highest total cost of ownership server at this site. They're now focused on another platform, which is the most expensive site, to try and get away from that. So the mainframe is now here to stay and is continuing to be enhanced. So we've had a real success at applying these tuning tips across the board, and seeing genuine results that have delivered benefit to the businesses we serve. Okay, I'll open the floor to any questions that you have. I apologise for keeping you so late. I obviously had more material than I realised I could get through with.
The leader has unmuted your line.
Great. Okay. So if you want to ask questions now, by all means do. Otherwise, here's my email address. You can contact me on this.
Hello?
At any time.
Right, the pound 5.
Oh, and if you can hear us, please unmute with pound 6.
Hello? Can you hear me? Hello?
Go on.
Hello? Can you hear me?
Hello? Yes. I have a question regarding the debug facility. Can you hear me?
How can you be muted?
I can hear you. Can you hear me?
Yes.
Yeah, I can hear you.
Okay. Can you actually run that on an online prod environment?
Yes. Can you hear me now?
Yes.
Can you hear me? Excellent. Good.
Yes.
Yes, you can. Yes. So if you have, if you're using transparent sign-on, for example, in Ideal, you can update the transparent sign-on member where you currently have run P1000. Let's say your program name is called P1000. Instead of run P1000, you say debug P1000. Okay.
Okay.
And that will single step through. Now there is a slight complication here. That's fine if you're doing that from your own separate session. So if you're signing on to Ideal and saying, debug P1000, no problem. If you're updating a transparent sign-on member that many users are sharing, then of course they will all go into the debug session, which is not what you want. So there is a technique that we came up with. If you want to send me an email, I'll just put.
Yes, it will.
We did come up with a technique to effectively run a little program to start with and test whether it was the specific user that wanted to do the debug, and then just turn the debug on for that user. So if you want to send me an email, and I'll send the details of that. I'll have to look it up. I don't have the details to hand because it's a while since I've done it. There's my email address is on here. Okay.
Great. Thank you. Yes, I can.
Okay, good.
Thank you very much.
Yeah. But it definitely the debug facility does work in fixed environments, in online environments, and even runtime environments where your production system doesn't have access to the source. The debug facility still works.
Great.
Okay.
Thank you very much. We had that question come up not too long ago.
Oh, okay, good.
Hi, Owen. This is Nancy. In the Plano office, we lost the audio, but now we called you back from my cell phone. So I was just going to get your questions this whole time.
Okay. Okay, Nancy, can you hear me now?
Yes. Yes. Thanks.
Oh, okay. All right, good. Did you need me to repeat? Did you get everything on the session that I went through?
Right. That's perfect, and the recording is still working, so I think we're fine. So.
Oh, okay, good. Right.
So, are there any additional questions? No? Okay. Well, we'll go ahead and end the meeting. Thanks, everybody, and thank you, Owen.
Thanks very much, all. Bye-bye.
Yes, thank you. Bye.